Hello Legacy students, Marsh here. So today we're going to talk about factoring polynomials of a degree higher than 2, aka the largest exponent we'll have in the front will be not a squared, it'll probably be a cubed or to the fourth. Basically, factoring is back and it's bigger than ever. You're not going to be putting your notes into this foldable, but I want to just remind you back to when we did this foldable. And it helped us factor quadratics. Similar steps are going to be taken to factor polynomials as well. So let's jump in here. So remembering, what does it mean to factor? Well, basically what does it mean to factor is to break apart into little parts being multiplied. Strategy is the same, but the answers are going to look a little different now that we're dealing with higher order polynomials. Basically, factoring is just the inverse of multiplication. It allows you to take something that was multiplied and break it down into something so that it looks split up again. Let's take a look at greatest common factoring version. So, for looking at a common thing that we're going to be able to take out, that's what greatest common factoring is. So the reason we do GCF first, you always want to see if there's something common. It's going to make your life a lot easier when you're looking for something in common. So I have 50x to the fourth minus 25x squared. So notice this is a fourth degree polynomial because it has a 4 up here. Well, what's common between these guys? Well, they both share 25, right? And then they both share an x squared as well. So let's factor out an x squared. So if I factor that out, I will get, well, this would be a 2x squared, right? And then minus 1. Then what we would want to do is make sure, especially on the next problems, we're going to want to make sure, can we factor this again? Which in this case, it looks like a difference of perfect squares, but it's not because of that 2. We can't factor this further. So that would be my final answer if I would just be asking to being factored the problem. Let's try group factoring now. These are similar. You guys already have kind of done problems like this. So I'm going to group my first two terms, group my second terms. So what's common between 30x cubed and 18x squared? Well, 3 can go into both of those. 10 can't, but a 6 does. So let's take out a 6 out of both of these. And then I see an x squared as well, right? 6x squared. So that would be 5x. So if I divide this by 6x squared, and then divide this guy by 6x squared, I'll get negative 3 there. So if I remultiply, I should get back to there. What's common between these guys? I think a negative 5 would do the trick. So I want this to be positive, right? Because this one was positive, so I need this guy to be positive. So that would be a positive 5x if I divide by negative 5. Divide this guy by negative 5. Get 5x minus 3. Notice they're the same, so then I can factor that out. And I'm left with 6x squared minus 5 for my final answer. So, trinomials in quadratic form. You guys are so used to 2x squared minus 5x minus 12. Now, these can grow bigger. Definitely grow bigger. But let's try the first one here. So, a times c, I can do my a times my c. So 2 times negative 12. So I'm looking for numbers that multiply to give me negative 24, but it will add together to give me negative 5. So I can expand this so that was just came out of the multiplication. And then I can group factor. So negative 8 and 3 I think will do its job. So I got 2x squared minus 8x plus 3x minus 12. All I did is expand that middle term so that it looks like I just multiplied out. So then let's figure out what we distributed in, right? Because we're going to be basically undistributing. So I'm going to multiply, that would be a 2x, x minus 4. And there's a 3 common between those guys. That'd be x minus 4 as well. So now these guys match, so I can undistribute out. That's what we multiplied in, was an x minus 4. And and we multiplied into there a 2x plus 3. So that would be my answer for that particular problem. That's old news. You guys have done these kinds of problems. Now let's try one that's a bit more muscular, if we want to put it that way. So I got 4x to the 6th minus 20x to the 4th plus 24x squared. Wow. Well, first thing, GCF. Is there something we can take out? Because I see a 4, a 20, and a 24. And I go, I wonder if I could take out a number. Well, they all share a 4, right? And then they also all share an x squared. So let's factor that out first. So this would be, if I would take that out of each of these, technically I'm dividing by 4x squared, right? I'm undistributing it. This would be an x to the 4th right here. So the 4's would cancel out, and 2 x's would cancel out with 2 x's up top. This would be minus 5x squared, and then plus 6. There we go. Now, I need to factor what's inside now. So, notice, guys, this x to the 4th, it's probably kind of, what is that? It's okay. Don't worry about it. It will actually work its way out. You're going to be factoring exactly the same. Your middle term expansion is just going to look a tad bit different. But we're still going to follow the same steps. We're still going to go 1 times 6, so we're looking for 6. We're looking for 5, negative 5 when we add together. Well, now it would be a negative 2 and a negative 3, right? So if I expand that middle, notice, guys, normally would have put negative 2x and negative 3x, but it's a squared in the middle, right? Not just an x. So what we're going to have to do is put squareds on both of those. So since it was originally an x squared, we need x squareds when we expand as well, because these two should add up to give me that, because otherwise then we're not expanding correctly. Let's factor out. Let's do some group factoring now. This 4x squared is just going to come along for the ride for a while. X squared, and I got x squared minus 2. Looks like a negative 3 can come out of there. That'll be x squared minus 2 as well. So my final answer, 4x squared, x squared minus 3, x squared minus 2. Now, double check. Can we do any other factoring? And I look at it, I do have subtraction, so in my mind I think, difference of perfect squares possibly, but 3 and 2 are not perfect squares, so I cannot break those down any further. So my final answer if I was just factoring would be that particular answer right there. Difference of perfect squares. Guys, we've talked about these before as well. First thing I'm going to ask, can I divide 16 and 81? Is there a number that they both share? Doesn't look like it. So, can't do a GCF. Well, technically 16x to the 4th. That would be technically 4x squared quantity squared, right? That would be that. And then this is technically 9 squared. See it that way? Well, I can then do just like we normally did when it was like 4x squared minus 9. One with a plus, one with the minus, because we're missing that middle term with an x squared in it. So then what I can do is take the 2 that we figured out, and then I will be complete. This factored out is that right there, because we were able to figure out what times itself gave me 16x to the 4th. Well, 4x squared. What times itself gave me negative 81? 9 squared. So, reviewing my factoring, what are you always going to want to do? You're always going to want to make sure there's not a GCF. If there is a GCF, you need to take it out first. It will make your life easier. If you cannot GCF, or if you already have, you're always going to check. If you have group factoring, if you have 4 terms, that's when you're going to do that. AC method, that is a 3-term fact. If A is 1, AC is not necessary. You can just jump immediately to your 2 parentheses. Definitely, like the one we did today in this video, I could have jumped to the 2 parentheses, but I wanted to show you guys how to do the grouping. And then difference of 2 squares, you must have 2 terms, they must be perfect squares, and they must be a difference, aka you must be subtracting the numbers. Don't forget to check to see if they're subtracting as well. And that's the end of this video. See you later, Sabers.